Now let us talk about two very important terms related to triangles. I'll be talking about medians and altitudes of a triangle. What do we mean by median and what do we mean by altitude? Let us see that. So let us start with our basic thing, a triangle, right? All of us know that we have a triangle here. See, let us name the triangle ABC. A, B and C. Now what I'll do, I'll just draw a line from vertex A to the opposite side BC such that it bisects the side BC, right? Say I have a line here, something like this. Say this is a straight line. Consider this to be a straight line. Say this is point M and this AM bisects BC. That is, BM is equal to MC. If a line satisfies this condition, then it is known as median of the triangle, right? So now a very genuine question that I can ask, that how many medians can be drawn in a triangle? You can answer this very easily. Say this line, this median was drawn from the vertex A. Similarly, from vertex B, I can draw another median which will give me such that it bisects the opposite side. Say this point is N, such that AN is equal to NC. Similarly, from the vertex C, I can draw another median which will bisect its opposite side AB, such that, say this point is, say, P, such that AP is equal to PB. Then these three, AM, CP and BN, are known as medians of the triangle. So in the triangle I can have three medians. Also, one more important thing, you can see here that all the three medians are concurrent at one point. Let us call this point as O. This point O is known as centroid of the triangle, right? The point of concurrence of the three median are known as centroid of the triangle. And what are medians? You already know, the line drawn from the opposite vertex to the side such that it bisects the opposite side. This is known as median, and point O, the point of concurrence of the three medians, is known as centroid of a triangle. Also, there is a very important property which is related to the centroid of a triangle. What that property is, the property says that this point O, that is the centroid, divides AO and OM in the ratio 2:1. That is, I can write AO by OM is nothing but equal to 2 by 1. Similarly, BO by ON is in the ratio 2:1 and CO by OP will also be in the ratio 2:1. So I can write it as BO by ON, and this will also be equal to CO by OP. This is all about medians of a triangle. Now let us come to altitudes. What is altitude, and let us talk about them. Say again I have a triangle here. Let us name the triangle this time PQR. Now from a point P, what I'll do, I'll draw a straight line to the opposite side from point P. I'll draw a straight line to QR such that P, let us name this point as M, such that PM is perpendicular to QR, right? I'll draw a line PM to the base QR such that PM is exactly at 90° to QR. Then PM is known as altitude of the given triangle. PM can also be represented as height of the triangle if we consider QR as our base, right? This PM will represent our altitude. So if I want to define altitude, I can say that length of the perpendicular drawn from the vertex to its opposite side is known as altitude of the triangle. Similarly, if I consider PR as my base, then I can take a line from here such that QN is perpendicular to PR, then QN will also be the altitude, right? And similarly, from the vertex R, if I'll draw a perpendicular line to its opposite side, then say let us name this point as S, then RS will also be the altitude of this triangle. So again I can say very clearly that RS, PM and QN are my three altitudes. So a triangle can have a maximum of 3 altitude. Again, you can see here that all the 3 altitudes are concurrent at a point. Let us name this point as Z. This Z is known as orthocenter of the triangle. This point Z will be known as orthocenter of the given triangle. So this is a bit of introduction to medians and altitudes of a triangle, and this what is the importance of this, how to use this, and much detail we'll be seeing in later videos.